Hi, I'm Kevin McAllister, President of Schuler North America. Thank you so much for joining us today for our Laser Blanking Technology Seminar presented by Justine Fonteyne, our Area Sales Manager in Schuler for the Americas. I will now turn it over to Justine and Brad Kuvin, Editorial Director for MetalForming magazine. Thank you.
Welcome to today's webinar, Dye-Free Blanking Class A Quality and Structural Parts, presented by Schuler North America and hosted by MetalForming magazine and the Precision Metal Forming Association. My name is Brad Kuvin. I'm the Editorial Director at MetalForming, and I'm pleased to be your moderator today. Thank you all for joining us. All right, so now it's time to begin today's webinar on dye-free production of quality, Class A quality and structural parts, which is possible even for high-volume serial production. Schuler has pioneered a way for manufacturers to produce blanks with no presses or dyes and achieve long-term, cost-efficient success with innovative laser blanking technology. Joining us today from Schuler is Justine Fonteyne. Justine is the Area Sales Manager at Schuler North America, and she is responsible for new equipment sales of conventional and laser blanking technology, along with automation and digital solutions. Through the combination of her technical background, international network, and specialized market expertise, Justine provides the Americas with a customized outlook to smart factory solutions. Please welcome Justine.
Hello, thank you very much for this nice introduction, and thank you of all of you for your time and your interest in laser blanking. So my name is Justine Fonteyne. I'm the Area Sales Manager of America's 4 blanking lines, and today I'm here in our North American headquarters in Canton, Michigan. So for everyone who is not familiar with Schuler, we are a German-based international company with more than 40 sites all over the world. We are providing metal forming solutions and are the biggest supplier of presses worldwide, but not only for presses, also for automation, services, process know-how, everything related to this topic, digital solutions. And today I'm super happy to introduce you to our latest innovation, our laser blanking line. And yes, I think we're good to go. Here we go. Before I start with the 5 smart solutions how laser blanking can improve your production, I would like to present to you very briefly what laser blanking actually is. So it's a form of blanking, obviously. So it's including a coil line with an uncoiler, threading unit, leveler, the roll feed, and then it goes into the cutting area. So this is the main difference. So instead of cutting with press or with a shear, we have here the laser cell, and then it goes into a stacking unit, and this one is pretty similar to the blanking lines you already know from conventional blanking. So we have concepts to run Class A parts for outer body, but also structural parts with different line concepts. Both concepts have in common that we are running with DynamicFlow technology. So this is a way to run the material continuously through the line without the need to stop before we cut. And this is the main reason how we can achieve such high outputs and target serious production as well. But laser blanking actually is not the only blanking line in our portfolio, so we have a great experience with blanking lines since the 70s. Coming from conventional press blanking lines, so they have definitely still a reason to be on the market. So laser blanking is the latest innovation, but of course It really depends on your portfolio which one is the best equipment you want to go with, depending on your portfolio and your business case. So we still have them in the portfolio, and I just want to briefly introduce to you in what scenarios what equipment makes the most sense. To start, here you can see our press blanking line. So we provide mechanical and servo press blanking lines, and those are perfect for shape blanks and high production volumes. So as soon as you do not have a lot of die change to do, you can really benefit from the high output of press blanking lines. So they still have higher output than a laser blanking line, and you can do whatever shape you want depending on your die, and also rectangular blanks with an oscillating shear, for example. This is an absolute reliable solution for outer body panels and structural parts as well. And especially for smaller parts, the big advantage is that you can run more than one part at one stroke. So 2 or 4 sometimes. And this is a big advantage that we do not have with the laser blanking line, as we need to run the complete geometry for each and every part. The second line is a cut-to-length line, very common. To be honest, it's not that much requested anymore, but we still have it in our portfolio. And this is a line that it's the fastest one. So we can achieve more than 100 strokes or 110 strokes per minute, but it's at the same time the least flexible line. So you are just restricted in your contoured blanks. You can just do rectangular blanks or trapezoidal blanks. We have the opportunity to also add a cassette with bow knives or S-shaped knives, with automatic cassette changes as well. But again, this is the least flexible solution, but the fastest. And at the very end is the laser blanking line. So this one is perfect if you have a rising number of different parts you want to run, or different materials that force you to do frequent die changes. The digital nesting has big advantage in nesting, so that we can be much more material efficient. And we saw in several business case calculations that it's actually the cheapest way of blanking, especially when it comes to new equipment investment. But we're gonna talk about this in a special point later. Okay, so now let's jump into the industry impact we have already. So as I mentioned, Schuler has a great history and experience in metal forming and blanking. So our company has a tradition of over 180 years. And since 2015, we were able to sell more than 40 lines, more blanking lines. And 15 lines of them were laser blanking lines. And we are very happy to announce that 5 of them are in the North American market. And I think this increase in laser blanking is also due to the change in the market. So I summarized 3 very general points. So one of them would be the increasing variance. So we see that the life cycle of cars in general are getting shorter. So that means you have much more models coming up more frequently that needs new or different die sets. We also see that there are a lot of new players coming into the market with the EV technology, and they are ramping up slowly or have different models, and are very happy if they do not need to invest in dies right away. So we see an increasing number of different shaped blanks we need to process in the market. Another big trend and long-lasting trend is the lightweight construction. So this one results in different materials. So we see a rising number of of aluminum blanks, but also high-strength material. The blanks themselves change, so we have a rising number of tailor-welded blanks as well, and structural parts with high-strength material. The last point I would like to mention is the intelligent capacity utilization. We see that the shifting of production within the production network is getting more and more important, and this also needs flexible equipment. In the bottom, you can see a great mix of leading companies in the automotive industry and also some of our references. Laser blanking started with a big project with Daimler in Germany, but since then it spread really all over the world, not only for OEMs, but also in the tier market, as you can see here. We prepared a short agenda for today. So we are talking about 5 solutions how laser blanking can make your production more efficient. So the first point we're gonna talk about is frequent die changes and how we can avoid them with laser blanking. The second one is increasing capacity. If you're interested to buy new equipment or you have a new model that you need to buy new equipment. Then we talk about the increase of volumetric efficiency in general and how laser blanking can support in that. Fourth point is material utilization. And the fifth one is how we can improve the downstream processes after blanking with our laser cutted blanks. Here, maybe just for reference, you can see a different line concept for structural parts. So for us, it's very important that we are designing the lines according to your needs and supplying the equipment you actually need for your blanks. And we are always open to discuss with the customer whatever they need and want and supply the perfect solution. Smart solution number 1 is frequent die changes. So die changes are optimized, that's not a secret, and most often prepared offline already, so that you just need to do the actual die change, but it still costs production time. So die change is always a downtime, so a time when you're not producing at all. And the second point with dies, and it's less considered, is that we have restrictions to dies depending on the material we want to process. And here you can see, this is an overview of the material mix of a car, that we have a very high amount of aluminum, for example. And aluminum is very sensitive and causes some difficulties in the processing because of that sensitivity. We heard from customer that they need to reduce the speed of the line because of dies making damages to aluminum blanks, so that at the end they had the same output on a conventional blanking line compared to a laser blanking line at aluminum parts. And we see that aluminum is rising, so we even have OEMs that are running only aluminum for their outer body panels. Another point is damages on edges, so caused by fly to drop stacker, for example. So that's the reason why we are using a stop-to-drop stacker to ensure that we have perfect edges and no damages when they fly against the guides. Second, materials, yeah. So the second material type I would like to talk about are the high strength materials. So here you can see advanced high strength and ultra high strength steel material. So those are most likely used for structural parts. And they're not only more high strength, but also thicker. So that means it causes a lot of impact in the cutting process, causing a lot of wear in the dies and also in the presses. And we see, so depending on how high strength it gets, that we come to a limit of the capabilities of presses and also of the knives. So we have a very high wear, and for the laser, actually it does not affect the output if you have higher yield strength in your material. So to summarize this topic, by avoiding dyes in the laser blanking process, you also avoid dye changes, obviously, and also restrictions to dye in your production time. And this is the reason how laser blanking can achieve up to 80% of OEE and overall hit a production of 4 to 6 million parts a year. So it's not as much as a conventional blanking line can do, as I mentioned before, but it's still absolutely sufficient for serial production in the car manufacturing industry. The second smart solution targets the increasing capacity you might want or need. So if you want to buy a new equipment in blanking, you should definitely look into laser blanking as well, as we figured that it's the most cost-efficient way of blanking. So the cost per blank with laser blanking are lower than with conventional blanking. And this is also due to our high output we can achieve. So we promoted that we can achieve more than or 45 parts per minute at some parts. I have a very generic summary of blanks listed here. Of course, those numbers are linked on material sizes or blank sizes and also thicknesses. But if you're interested in real output data, you're always welcome to send us your parts, and then we are providing some output estimations. And that's actually something we fix in contracts, and we are also able to prove in final acceptance tests. So those numbers are real numbers and not just marketing numbers. So to start with, I have here the rectangular blanks. Those are easy shapes, and especially with smaller feet length, we can achieve very high outputs. When it comes to hoods, for example, we are still at 35 parts per minute. Rectangular blanks or trapezoid blanks can achieve 36 parts per minute. And as you can see here, when the part is getting bigger and you have more cutouts and more complex geometries, then the output drops. So that's also the reason why we really need to figure out what your portfolio is to make sure that we provide the right equipment. So it's not necessarily laser blanking the best solution, but especially for this scenario, it's definitely worth to look at it closer. Structural parts, just to give you an example, can run with up to 16 parts. Here it's a bit less because of the complex geometry, and structural parts tend also to have some holes and cutouts that makes it slower in general. And here I have just a small video showing you how production is actually looking. So this is a line installed in Germany, in Halle, in our smart press shop. And they are producing mainly Porsche parts. In the video you can see a door, and so here we are running 12 parts per minute approximately. You see that the material is really flat, lying on the belts, and here you can see a little gap. So this is the gap that is moving underneath the laser to make sure that we are cutting correctly and not cutting the conveyor system underneath. And we are blowing down the laser dust in that gap, and we are also able to eliminate smaller scrap pieces there in order to have a safe and reliable transportation of the good blanks into the stacker and cleaning devices. Smart solution number 3, increasing volumetric efficiency. So if you are interested to buy new equipment, space is always a topic. So either you have it in an existing facility or in a new building. Space is also every time linked to costs. And this is also one reason why laser blanks are more cost efficient, because we have less initial investments in building and infrastructure and the dies as well. So looking at the overall picture, those blanks are cheaper. And here I would like to show you what we can actually save. So of course we can save everything related to dies. So you do not need any die storage anymore, and you're not restricted in your die storage space anymore to use laser blanking, so you can take whatever job you need to do. Additionally, die maintenance areas. As we have no dies, we do not need any die preparation or maintenance anymore. We have a saving in coil space as well, as we can do the nesting according to the coils that you have or that are easy or cheaper to get, and reduce the overall coil storage. We do not need to flip the blanks anymore, as we are flexible in nesting them in the way you actually need them to be. And finally, we also have less pallets we need to store. So we heard from several customers that they're trying to keep productivity up and to avoid frequent die changes, so they produce in advance. So if they have a coil, even if they don't want to have this big amount of parts, they would run the whole coil through just to avoid frequent die changes. And this causes more storage for blanks that were already produced but not needed yet. And this is space we can save, as we can produce just in sequence, as our product changes are so fast. So we can do them basically at the push of a button by choosing already programmed laser programs, and then we are ready to go. So this is within a few minutes. Additionally to the floor space itself, we also save a heavy press foundation. So our laser blanking lines can basically be built wherever. So we have customer, for example, they use their former coil storage to build the laser blanking line in there. So we do not need any press foundation and also no deep loop. So the reason is that we are running continuously, so we do not need any buffer. We still have a small surface loop to have the flexibility to guide the material correctly through the laser blanking line. But other than this, we do not need 5 meters loop pits. And this is also a big cost saving aspect. We do not need any special infrastructure to handle dies. And also coils, so you need to provide coils, obviously. We have a customer that is using a different bay with the crane having the coils there, and then only a small shuttle to provide the coils to our uncoiler. So this is also a solution, but actually we recommend to have a crane for the coil setup, and it also helps maybe if you want to remove something or change something in your hall. We designed our line to be mounted on floor only. So it's a kind of modular system. You can see the platforms here. So in that way, we reduce the foundation work that needs to be done by the customer to a maximum. So the only thing we need is the connection to the utilities and the main power supply. You can see here. So we have one trench, and then we are distributing everything in our platforms. And the whole line is installed previously in our facility first. So we have already all the cables installed and at the right length, so that we are much faster on site, as we can basically just plug everything and start. Our concept also includes those cabinets as a safety fence. So again, our design is dedicated to have less footprint as possible and to increase your volumetric efficiency as much as possible. Our laser blanking lines are also emitting no noise or vibrations, so they can even be placed very close to a neighborhood where people are living. But on the other hand, it's not sensitive to vibrations, so we can also put them into an existing press shop. So our laser blanking line is not only flexible in the parts they're producing, but also in the way you can build it. Okay, here as a reference, we would like to show you how we can save the space underneath the blanks, the laser blanking or blanking lines. So here you can see that the laser blanking line is completely mounted on floor. We just have here a little connection to the scrap conveyor system. We are very flexible to adapt the scrap conveyor system or whatever box you would like to use here. And on the other side, compared to this, we have this conventional press blanking line with the deep basement for foundation and also for scrap separation or scrap elimination, and the deep loop pit. So basically you're saving 6 meters or roughly 20 feet of basement work underneath the blanking line. Solution number 4. So here we are talking about material utilization, and this is getting even more important now as our material prices are rising a lot in the last time, and it's getting also less on the market. But even before that, we saw the trend that less rectangular blanks are requested. So actually the rectangular blanks are still quite common as they are very easy to get. So you can get them from a shear line, cut to length line, but also from your press. But those rectangular blanks, even if they are fast and easy to get, they are not optimized in scrap. So in general, you do not need a rectangular blank, but a shaped blank. And with laser blanking, we are able to adapt the straight cut to an S shape, for example, or a bow cut, or whatever intelligent cross cut you may need to increase your material utilization as you're closer to the part that you are actually needing. And in this way, you save material. And for the laser blanking line, it's making not a big difference in output if you're just doing a straight cut or a bow cut, for example. So here we prepared a short video. So this is again in our facility, this is in the smart press shop again. And here you can see a bow cut. So this one would run around 30 parts per minute. It's a hood. And you can see how the lasers are sharing the work, so that we make sure that the material is processed in a reliable way through the laser cell. We have a very lean concept as well, so we have no more big gantry on top of it. So in the last 10 years we are doing laser blanking lines, we gain a lot of experience, and we also always try to improve our equipment. So now we end up to have a very lightweight construction that is also better for accessibility or better maintenance and things like this. And it's very dynamic due to this lightweight construction, and this is also the reason how we can achieve such high outputs. I would like to show it again so that you can see how the material is constantly laying and supported by the belt materials. And you see also the lasers are moving back and forward to do the cuts, and the material is running continuously through the line. So this is basically the key of our DynamicFlow technology. But not only in rectangular blanks, we can improve the shapes of the blanks, also in shaped blanks already. So here you can see, for example, that we have a door with some areas where you can actually see the straight knives. For dies, it's always better to have straight cuts. Bows are always a bit complicated. So you always have a compromise and restrictions due to dies. Also, if you want to save a little money, they are getting more easy. So with laser blanking, you're completely free to program whatever you want as a part, and you can optimize it to the actual final part you want. You also have the possibility to do edge-to-edge nesting. And this is where it becomes interesting also in terms of material utilization. So with laser blanking programs, you have much better material utilization as you can nest your part wherever you want and how you need it, and not how you have to do it because of die restrictions. Another smaller but still an advantage is compared to flatbed lasers. So we know that in the trial process, a lot of laser blanks are used, but coming from flatbed lasers. And they're in general needing a grid around and some separation strip to be able to remove the scrap out of the flatbed laser automatically. And this causes a lot of additional material that you cannot use for your blanks. So So that would be this scenario. And with the laser blanking line, you can nest them to infinity, so that you do not need any separations anymore, and you can also use the coil edges as part edges. So that way we can save up to 10% actually, and also produce it much faster than conventional flatbed lasers. So as an example, those hoods may have maybe 3 parts per minute, while the laser blanking line can run them 30 parts per minute. So that means if you have a laser blanking line in your production already set up, you can also use it to squeeze a little try-out job in between, run it for 10 minutes, and you have already the blanks you need for your try-out process. And you do not need to wait for months to get them. Material saving is also a big cost saving. So 1% material saving equals $1 million savings per year. So this one is based on an outer body portfolio and on 300,000 parts cars a year. If you want to have more information about this, or even if you want to know how much saving we could achieve in your portfolio, we can definitely do a workshop about this. So we are happy to support you in that. Okay, so smart solution number 5, improving our downstream processes. So this is something that comes directly with the process. So laser blanks are different than conventional cut blanks. You can see it here in this picture. So this is a cross section of a die blanked material. So you can see here how the material is squeezed together at the very beginning. Then you have a small cutting section here, and then it's breaking somehow. And you can see here on the bottom that you have an edge hardening in the area where you squeeze the material. And compared to that, we have the laser cut where we have a very homogeneous edge without any hardening zones or heat effect zones. So this cross section of the laser is very homogeneous, and this leads to a couple of advantages. I just provided 3. So we have, by doing laser cuts, hardly any burr. So there is a little something, but it's not the burr like you know it that can fall off in your forming process. Especially for aluminum blanks, we see a lot of flitter in the dies that requires a lot of cleaning in the forming process. We even heard from customers that they're reworking the whole edges to make sure that there is no flitter at all going into the forming process, causing damages or scratches in on the blanks. So this is something you would like to avoid. And this can easily be done with laser blanks. A second point is less 3D trimming. So this is more relevant for structural parts. So after forming in general, they are 3D trimmed. And with laser blanking, we have the possibility to improve our geometry, even if you're already running production. So we can optimize it better and better and better to reduce the 3D trimming effect at the end. So that way you can avoid investments maybe in an additional 3D laser cutting system. You probably won't be able to eliminate the process completely, but at least you can reduce it. And then the other example is relevant for the hot forming process. So in that case, aluminum silicium material is used, like UZ-bore, for example. And by cutting the blanks, we are squeezing this aluminum silicium material into the edge. And this is actually causing the dripping on the rollers that are quite expensive in the hot forming process. And with our laser cuts, we are actually burning a little bit of this layer, and that way we can reduce this dripping by 30%. So we did some trials there, and it's incredible how we can increase the lifetime of those rollers by using laser blanks. Yes, so that's basically it. Now we're having a short summary, so that we can conclude what we learned now in this webinar. So the first topic we talked about were frequent die changes or restrictions in general related to dies. So with laser blanking, you are able to do a very effective small batch productions of several material types. So again, our laser blanking lines are also able to run all kind of materials, from aluminum to steel, high strength steel, stainless steel. So we are completely flexible here. The second point is increasing capacity. If you're looking into new equipment, then laser blanking could be the most efficient and cost-efficient way to do so. We talked about output rates. So often laser blanking is a bit known for low outputs. And I hope that I could convince you that we can achieve definitely serial production with laser blanking as well. And actually we saw also that sometimes laser blanking lines achieve much better outputs than conventional press blanking lines that are actually running in the market right now. So laser blanking lines can definitely be as much or even more productive than conventional old press blanking lines. So that's maybe also an interesting fact. Increasing volumetric efficiency, we talked a lot about space requirements, mainly in existing buildings, but also new buildings. So in general, you would like to build your buildings as small as possible. And laser blanking also support in that, as it needs very little floor spaces for everything related to dies. The line concepts as well, so we have different ones, but in general are similar to the footprint of a conventional press. So the saving is more about everything related to dies. We talked about material utilization, intelligent nesting, and part optimization for better material utilization. So here again, we are very open to also do some workshops with you to help you to improve your material utilization with laser blanks. And the last point we talked about was improving the downstream processes as we are using laser blanks. Getting started. As I mentioned, we are happy to provide you part simulations, so just contact us. We need DWG files to do part simulations, so we do preliminary ones or just for ideas, but also like serious binding ones for contracts. And this helps a lot of time to do the business cases so that you have a better overview which equipment is better for you. So we do this also with customer. Some of you I know we already had them together. So we are comparing the overall costs of a conventional blanking line and the laser blanking line, and consult our customer what equipment would suit best to the special business case and part portfolio. And the third workshop we promote here is the part optimization workshop. So this is relevant most likely for a customer that already have a laser blanking line. And here we can adjust the parts in cooperation with the downstream processes. So it always needs to match with the forming process. So we do also include our know-how from this area to make sure that you have the perfect blanks for your actual part. Yes, so that's it. At least with the presentation, I'm really looking forward to your questions now. And I'm always available via email, so just send me your questions even afterwards, or contact me if you're interested in more detailed information. So this presentation was briefly about the advantages and some scenarios, but of course we are also open to talk about our concepts in more technical details in the next step, and to show you the different concepts we have in our portfolio. So that's it. Thank you very much.
Very good. Very good presentation. Thank you. So yeah, several questions, Justine. Can the laser system perform laser welding, which I guess would be useful for stacked material, tailored blanks?
So yes, our line is not able to weld, and we know that the edges actually from the cutting are pretty good for welding. The only problem is at the moment that we are not targeting the tailor welded blanks accuracies at the moment. So what we can do if you're interested in tailor welded blanks or structural blanks, send the parts to us, come towards us, and then we can discuss what accuracies you need where. We are also working together with our sister company, which is also part of the Andritz group, called Sutec. They are providing laser welding machines, and we are in close contact to actually match those processes to be able on the long term to process tailor welded blanks as well.
Very good. Can you talk a little bit about feed rate of the material and the thickness?
Yeah, sure. So our laser blanking lines can achieve thicknesses up to 3.5 millimeters. We would increase the laser power when it's getting thicker, and then one point it's getting critical with the leveler. So in case you would like to run high strength material, very thick high strength material, we come to a certain edge here with the leveler. For the laser itself, it's not a big deal. In that case, we would increase the laser power from 4 kilowatt, which is our standard in outer body panels, or 6, which is our standard for structural parts, to even 8. So we are quite flexible and add whatever you need.
Very good. Thank you. Question has to do with isolating the equipment from press vibration. So if you're operating a line next to presses, do the presses need to have extra vibration isolation, or does the laser cutting equipment get typically installed on a concrete?
So, yeah, that's a good question. We have it a lot. So normally we have a bay that is disconnected from presses with the normal seam, and this is completely sufficient. But we also have the possibility to provide isolation plates for the laser cell if the customer feels more confident. We also support with some vibration measurement documents that we can provide to make sure that it's matching. But in general, if it's in a separate bay, it's fine. We're getting difficulties if it's really on the same concrete plate like the presses. But in general, as it is so big, it's disconnected anyway, and this is sufficient.
Excellent. Okay. Thank you. Question is, so conventional blank stackers have dual stations to handle trapezoids and other shapes where two or more shapes may be produced and stacked. So the laser blanking line only has one station, right? So is this because the blanks are stacked using a stop and drop process where two stacks of different shapes can be stacked in a single station?
So actually our stacker for outer body panels is exactly the same, also from conventional blanking lines. So we have two stacking areas, and if the parts are small enough, we are also able to stack two parts on one stacking card. Sometimes we even provide 4 stacking cards so that you can prepare and run continuously, even if you have big left-right parts. And in addition to this, because sometimes we know, especially for structural parts, it's better to have even more stacking pillars on your stacking card. We have our gantry solution. I can move backwards real quick. So here. So in that case, we would pick the good part and place it here. And with our turning device and gantry solution, we are even able to pick and place them very close to each other, so that we are even more flexible than a conventional stacking system from press blanking lines. And we can run continuously, so we would stack everything on one card, and as soon as it's full, this one goes out and we start to place everything on this side. So you can run continuously without having to stop because your stacking card is full.
Hi, this is Luke Wren, senior editor with MetalForming magazine. Brad just dropped off, so I'm just going to take over for a couple of minutes. If I'm trying to catch up on the questions, but if you have a couple other comments on what you just previously addressed, we'd appreciate it.
Yeah, sure. So we often have also the question if it's possible to mark blanks with our lasers. So actually this is not really possible, but we are able to add a marking system, and additionally to that also a complete track and trace system. So this is part of our digital solutions, and we can connect all the production data, for example from the leveler or the laser constitution, power, to a certain part, and we can track it easily with the tracking number that can be applied with an additional laser. So this is pretty cool, and in the Smart Press Shop we even add some additional measurement equipment, for example oil measurement equipment, and we are linking the information of the oil film to the blank, and on the long term the idea is to transmit the information to the forming process, and that they can reduce, for example, the re-oiling or to adapt whatever is needed only to the blank. So this is pretty cool and already implemented at the Smart Press Shop. So you heard me saying it a lot. So this is because it's kind of our showroom. So the Smart Press Shop is a company 50% owned by Schuler and 50% owned by Porsche, but it's an independent company producing parts and acting like a tier on the market. but we have the possibility to get feedback from our production. And this is very important because we would like to improve our digital solutions and go into connected factory solutions and smart solutions on apps, for example. And therefore we need those big data analyses, and we track this and improve this with the help of the Smart Press Shop. Maybe another addition. So this is also a great reference line. So if anybody is interested to see the actual line running, is always welcome to let me know, and then we can organize a reference visit. It's in Germany, but it's very nice there.
Well, thank you very much. Brad is back on, but there is another question here regarding the handling of edge oxidation, if you can address that.
Sorry, what was the question?
On the handling of edge oxidation.
Oh, okay. So I think this is related, and so I don't know anything about edge oxidation, so we do not have problems with our cutting process causing erosion on edges. I'm not sure if this question maybe also targets hardening or heat effect zones, like at CO2 lasers, for example. We are using fiber lasers, and they're very powerful and evaporating the material nearly immediately. So we do not have any effect zones on the edges. So I hope this answers the question.
Okay.
Yeah, Justine, this is Brad. Can you hear me now? Yeah, you can hear me. Good. So sorry about that. We dropped off, but I'm back. Yeah, the question that Lou's referring to talks about BH steels and the mechanical properties that might be affected by laser cutting. So I'm assuming that's related to heat affected zone.
Yeah, we have no heat affected zones with our lasers because the time. So with CO2 lasers, we needed to hold the laser spot a long time on one spot. So the energy went into the material a lot. But as we are evaporating within milliseconds, we do not have this effect anymore getting into the material.
Okay. All right, good. Thank you. I don't know if you answered this question while I was trying to get back on. Did you talk about the coil? Can you talk about the coil change process that you're using, or did you address that?
So we are using the same coil process as in blanking lines. So we prepare the coil offline, then it's picked up by the uncoiler. Then we have a threading. So we are peeling up the first winds to avoid dust and dirt getting into the laser cell. So we would crop the two, or maybe only the first layer, and then it goes into the press or the laser cell.
Right. Okay. Can you talk about tolerances while cutting, particularly in 3 dimensions, and especially in high strength steel panels? What kind of tolerances are you able to hold?
Okay. So we are not doing any 3D cutting. So we are just providing 2D blanks at the end. Our accuracies in structural parts, it depends a little bit on the feet length. So for smallest feet length, we are able to achieve plus minus 0.3 millimeters. When it's getting longer feet length, so a meter or something, then we are at plus minus 0.5 millimeters. And we know that in some special cases, this is not sufficient. So we are talking with our customer in what precise situation or spot the accuracy is needed. For example, for a centering hole or something. And then we can adjust our cutting strategy to achieve higher accuracies in that special spot. So that means, for example, or if you have two edges that needs to be super accurate to each other, we would make sure that everything is cut with the same laser, and while it's cutting, there's not the second laser moving. So those are a little bit our tricks, how we can improve accuracy on a certain spot. But this is nothing we can do for the overall equipment or part. So that's why we prefer to communicate plus minus 0.3 for structural parts.
Okay, good, thank you. Question is related to dust removal. How are you handling dust removal? Is there a downstream cleaning station or?
Yeah, so that's a good question, because especially for Class A parts, you need to remove the dust on aluminum planks to avoid scratches on the surface while stacking. So what we are doing, we have a lot of features. So first of all, we have a brush cleaning device for the blanks. So laser cutting dust will be removed off the blanks before stacking. In the laser cell itself, we have belt cleaning systems to make sure that the support of the strip material is always clean. And for the dust itself, we have here, you see the little doors. So this is for slag chutes, or where we collect all the dust. And you can remove them, so they would drive out until the laser protection enclosure, and then you can pull them manually, clean them, and put them back. So those are the slag boxes. And we highly recommend to also change them with different materials to avoid an explosion hazard or something. So this is very important that we separate it as much as possible. And the third area where we have dust is in the filtering system, the air filtering system. So here we are compensating it with calcium carbonate. So to make sure that we have no explosion hazard there as well.
Excellent, good, thank you.
And maybe what is also very interesting, we have those chutes with that are guiding the dust downwards, and this part is closed, so you do not have the dust going everywhere in your machine in the laser cell either. So it's very controlled, the dust flow.
Yeah, very good. Cutting round holes, do you use a rotary axis, or are you using circular interpolation of the X and Y axes?
Yeah, so we are using the normal back and forth movement of the lasers, so there is no extra rotating device included.
Okay. Do you want to mention what type of fiber laser source you're using in the machines?
Yeah, so we are using IPG lasers. So it's an American and very common laser supplier. Yes, it's a fiber laser, and we figured that this is the best way to do also the movements, as it is very flexible and very easy to maintain also. So we are very happy with this.
Very good. Okay. Any other developments with the technology? Any trends in laser blanking that you care to comment on that you're seeing in the market today? Types of markets where it's being used?
Yeah, so we do see a lot of requests in tailor welded and structural blanks, hot forming blanks as well. I think it's related to the wear and also the difficulties with welding edges and things like this. So this is something we we are working on. We also see the digital solution coming up more. So as I mentioned before, we have this track and trace system now where we can link all the production information to a certain blank. We had a lot of requests. So for those of you that are familiar with our first laser blanking systems with the robots, so we learned that robots are not necessarily the best way for scrap separation, as we need an additional tooling that is depending on the parts. So we designed line concepts that are completely tooling free or uses universal toolings. So yeah, we always try to adapt to the needs of the customer, and we're always happy to receive feedback so that we know what the issues are and that we can find good solutions.
Sure. So, and I'm sure many of your customers are interested in turnkey solutions, right? So Can you talk a little bit about how you achieve, turnkey installation of your laser blanking lines?
Yeah, so we provide everything if requested. So not only the equipment, but also transportation, sometimes even duties, the whole rigging, commissioning, launch assistance. So it's all available with us, but we can also adapt. So sometimes the customer prefer to provide their own rigging or think they can or have better deals with transportation. So we are completely open to discuss the scopes here. So
Thank you. Can you talk a little bit about maintenance and the availability of spare parts and how you handle modernization of the line?
Yeah, sure. So the question is probably because it's a German-based company. So actually we have a lot of facilities in the US as well to support with spare parts or modernization or launch assistance. So actually we have the biggest service infrastructure in our business field in the US, and not only in the US, also in Mexico, and we have representatives in Canada. So we are an international company and providing the support wherever our customers are.
Very good. We got one last question, but we've got a little bit more time if anybody wants to ask anything else of Justine while we have her on the line. You talked about the laser, what type of cutting head then are you using on these systems?
So we are using Precitek heads. They're also quite common. So actually it's a laser blanking line, but the know-how or what makes the line special is not necessarily the laser and the laser head. It's the whole blanking process and the DynamicFlow technology we are providing. So this makes actually the Schuler equipment special.
Okay, good. Common problem with coil feeding, right, is camber at the coil edges. Mm-hmm. So how do these systems deal with camber?
So So we have special features in our coil line that we can always discuss in detail that are guiding the material. This is also the reason why we still have a loop, because we need the flexibility to guide the material into the laser cell. If the camber is getting too much so that we cannot compensate with the equipment in the coil line anymore, then we have also the possibility to, and this is completely automatic. So the strip material is tracked all the time, adjusted all the time, like in a closed loop without any interaction of the operator. And if needed, we add also an offset of the laser program to make sure that we are actually cutting the material out of the strip, even if it's a bit offset. So this is done completely automatically in our line. But of course, if it's too bad, then we are achieving some limits as well. But general outer body or structural coils we can run.
Okay. Well, I think we've exhausted all the great questions from our audience. So I want to thank everybody for asking questions. Thank you, Justine, for a really informative and detailed presentation. We got a lot of good feedback already from our attendees. So you did a great job. And again, thank you to our audience for attending the program. We hope everyone found it to be a valuable experience.
All right, hi, I'm Brad Kuvin, Editorial Director of MetalForming Magazine at the Precision Metal Forming Association. I'm here at Schuler North America with Kevin McAllister, President of Schuler. Hello, Kevin.
Hi, Brad.
How are you doing today?
Very good, thank you.
Excellent. So, Kevin, we just finished our collaborative laser blanking line seminar. How do you see this technology changing manufacturing standards moving forward?
That's a great question, Brad. I mean, you know, I go back to customers' discussions that I've had, and there's some topics that are coming to the forefront. One of them being flexible manufacturing. I read a study on the weekend, an automotive study, that talked about 245 different models being introduced over the next 4 years. And on an annual average basis, that's 50% higher than the last 20 years. So more than ever, it's going to be important to have flexibility in manufacturing where you can get the products to market, and yet you don't know yet whether you're going to be producing at a mass level or not. And so it's being able to produce those small batches and get products there. The other demand that we're seeing from customers in flexible manufacturing is the materials. Again, this is a drive to EVs, which we'll talk a little bit more about, but it's lighter and stronger materials. And so that is also a request that we can deal with in the flexible side. The other aspect which I hear a lot is volumetric efficiency. And this is about producing using less space. And it's not just about new plants, it's also about existing plants where you can fit our technology within and use a lower footprint. And of course, with costs going up for construction, even real estate prices going up, I mean, again, this becomes an important factor. And as always, it's producing for less. I mean, reduce capital investment. I mean, if they can, again, produce for a lower cost, that's also important for our customers. And one that we're seeing come more in the North American market, it's been a focus in Europe for years, is sustainability. I mean, now with the increase in raw material cost in particular, I mean, the less scrap you produce, the more efficient and lower cost your overall operation is, among other things. And as you just heard with our intelligent software, we can actually program the parts to use less material and have less scrap in the end. So it's you know, a good fit. When I look at the technology, this dye-free laser blanking, I mean, it checks all of those boxes of those critical items for our customers.
Kevin, tell us about Schuler North America's core competencies. Where do you see the strengths of the company?
Yeah, I mean, our primary focus here, Brad, is really as a service company. I mean, we have manufacturing facilities around the globe, primarily in Germany and Brazil. And our role here first starts with service. And with service, I'm talking about spare parts, modernization. And that is our primary competency here that we really focus on, including training, development. The other part is new equipment sales, where we actually support the sales process of engaging with our customers here on selling new capital equipment, as well as with project management during execution. And then last but not least, we have a hydroforming technology center here. And this is where we actually produce parts, hydroforming parts for customers, as well as designing dies and producing dies to support their hydroforming presses. We have in North America, which includes Mexico, over 200 employees. And we have in the US, we have 3 facilities here in Canton, Michigan, including our global headquarters where we are today. And in Western Michigan, we have BCN Technical Services. And that company there, as you can see on my shirt, I have the logo here, is supporting our Bliss Clearing and Niagara products and that installed base of customers that we have there as well. And then we also have in the US a service location currently in Austin, Texas, supporting a key customer down there. In Mexico, we have 3 locations, including our primary headquarters in Puebla, Mexico, just outside of Mexico City.
Kevin, Schuler is German-based, so for the North American market, how does service, spare part orders, and modernization work?
Yeah, if I may, Brad, further clarify that we're German-based, but we're a global company. We're present in over 40 countries and we have 5,000 employees. So we are a very large company and supporting our installed base around the world. When we talk about service, I guess the first thing to know in the 3 years that I've been with Schuler, it's been a pleasure to be with the market leader and the technical know-how that we have here and how important that is in leveraging and supporting our customers. And really for me, service starts with having highly skilled techs. I mean, the most important thing for our customers is keeping production running. And at the end, I mean, it's important that we have the right people that are available when needed to help them get back up and running. And we do invest a lot. This year, we've invested over $750,000 in training our people. As we get new technology on shore, we make sure that our techs are involved in those projects and that they're gaining the knowledge needed to respond to customers. So as always with the company, and ours is no different, our success is always based on the people, and this is where we invest heavily. And our presses have been in service for decades, and I'm shocked sometimes when I see the presses that as I go visit customers, how long they've been there. And a big part of keeping those going is doing the upgrades and retrofits on those. And the important part for me is we don't just service our own equipment, we also service other brands. I would say almost a quarter of our business is based on our competitors' presses, where we're asked to come in and to do upgrades and add other enhancements to those equipment. So it's an exciting time in the market. We're lucky to have such a large installed base of customers, and we will continue to invest in supporting in them. And a last piece of service I would mention is the fact that we tailor service contracts for our customers. And that is a matter of we can provide them the service that they need, and we will often review them on an annual basis to see what they used, what they didn't use, and then retool it for the following year to make sure we have that support for them.
Kevin, as a supplier to the metal forming market, what trends are you currently noticing, and how is Schuler North America catering to those trends?
I mean, it's an exciting time. If I look at the automotive industry, of course, anybody that reads on the industry, it's all about electric vehicles. I had mentioned earlier the 245 models being introduced over the next 4 years. 60% of those are going to be electric or hybrid. If I look at Schuler Group-wide last year, almost 25% of our orders were in what we call the e-mobility space. And it will only grow going forward. And so it's an exciting time. And when you ask what solution we provide in the e-mobility space, a key one for us now is developing and providing press lines for producing battery cans. And what we've recognized is an opportunity to expand further in that space. And we're now working on further developments, including acquisitions, to expand in the battery cell manufacturing. So that would include the cell development as well as the finishing. And so it's an exciting opportunity, and you can expect to hear news from Schuler in the future about the steps we're taking to get a bigger share of that market. And again, I mean, if I look at the press over the last year, I mean, there's been tens of billions of dollars announced in this space by various automakers, both the incumbent and the new OEMs. Another space that we look at is new materials. Again, I mentioned earlier, it's about lightweight material, again, driven by electric vehicles. But one case of this is composite materials. We're now seeing opportunities coming up, including a major order we had last year with a kitchen and bath customer, providing tub and shower enclosures. Again, they're building a brand new plant in Arizona. We're looking at aerospace. We're talking with customers. Wind turbine blades is another opportunity. So again, that entire space is expanding.
How involved is Schuler North America in the Industry 4.0 sector?
Oh, that's a great question, Brad. That one hits deep in my career. Didn't mention earlier, but I'm a control systems engineer. by training. I graduated as electrical engineer, but got involved very early in control systems and programming, and an exciting space. And while we're known traditionally as a mechanical engineering company because of the large presses we deliver, this is an exciting space. We live in the information age. It's always about having information quickly and readily available so that our customers can make decisions when they need. Another thing that I've really enjoyed since joining Schuler is we have customer-driven innovation. It's not about engineers sitting back in a lab and developing products and then trying to find a market. It's about listening to our customers and providing what they need to fit their needs. And we are investing heavily in this space. We have a digital suite that we're investing in heavily, and the products that we have now include visual die protection. And this is a camera-based system with customized software where we can save our customers considerable downtime and cost by preventing accidents in the die space before they happen. We've already sold 34 of these globally. And what's interesting for me is 2 of the ones we sold here in North America, again, have been on competitors' presses. At the same time, it's not just something we can do for new equipment. Again, we can retrofit these solutions on existing equipment. Monitoring solutions, we've sold over 70 of those globally. And this is again about providing the key and critical information from the customer's equipment and making it available even on their phones. When they're at home on vacation, they can actually monitor how production is going and if any actions need to be taken. We have a track and trace solution. This is one where you can follow a part from the very beginning of the process and trace it throughout the entire process to the end. And from a quality point of view, if they ever run into an issue in their process, they can actually track that back and try and quickly determine where the problem exists. And there's many more solutions. We could go on this topic for at least an hour. And really it's about, for me, providing reliable and simple solutions for our customer to help get to a higher overall equipment effectiveness, or OEE.
Schuler North America continues to flourish throughout what have been challenging global conditions, supply shortages. How does the company continue to succeed and overcome these obstacles?
Yeah, I guess the most important point for me there, Brad, is Schuler is a company that's been around for close to 200 years. It's a remarkable history, and out of that we have a culture, and I mentioned the global nature of being in over 40 countries. What has really been exciting for me since I joined is it's really about supporting each other and having a collaboration. I mean, we don't have every answer here to solve every problem, and it's that ability to work with and across the company to solve these problems. Another important aspect for me is having the transparency with our customers. If there's a particular issue we're dealing with on supply and we can't necessarily solve it one way, it's an open dialogue with the customer about developing an alternate solution or an alternate approach that again gets the project delivered faster or whatever process we're trying to solve for them. But deep in my heart, the most important thing is people. I mentioned the challenge we have in this country, and it truly is a fight for talent. And for me, it's one that we're very focused on with our people strategy. We want to be the employer of choice. And that takes a lot of sweat equity, if you will. And it's a matter of investing in 3 key areas. One is talent attraction. We have a new HR director that's joined us, and he's been fantastic. And among his many skills, one of them is recruiting. And this is where we brought in-house ourselves, going out and recruiting people directly out of the market instead of relying on traditional headhunters. This is taking ownership of it. We also have a very lucrative employee referral policy. You know, some of our best employees have come through referrals from our existing employees, and it's very important that we bring talent in that way. We also talk about training and development. We want to give people a future, and this is about developing a career path and also making sure that we're training our people. We're rolling out with our managers training this year. 360 surveys. This is an evaluation for them as individuals of how they're perceived within the work environment. And it's important that they all have that recognition of who they are and how they're perceived so they can be more effective in their job. Another important element for us, Brad, is our engagement with the community. We formed earlier this year an employee committee where different people from different departments get together and organize events. It's that engagement that will help people feel more like this is a home for them when they come to the office every day and something that they're really proud to be part of. And you know, when we also talk about talent, what has been most impressive is the fact that we've been able to hire 60 people in the last 10 months in what is a very challenging market. And I'm amazed with the talent that we brought in, including our marketing and communications manager, Jamie Bartholomew. And last but not least, it's the retention piece. And again, it's not only being an employer of choice, but again, providing people a career path that they know what their potential future could be if they continue to perform in the right way. And for me, this is a battle that will continue and an important area of focus for us moving forward is to continue to develop and retain and keep our employees.
Kevin, lastly, can you shed some insight onto Schuler North America's strategic plan? What can we expect from Schuler North America?
Well, given all we've talked about earlier, Brad, I mean, you can expect more of the same, honestly. It's, again, our primary focus here as a service business is we have to grow. And we have to make sure we have our capability, continue investing in the training, bringing new employees. We're very fortunate. We look at the market conditions. We had a record year in order intake last year, 40% higher than any previous year. And so, again, we have to take advantage of these conditions and, again, make sure we're well positioned in adding and growing our organization further. Over the next 3 years, our strategy plan includes growth of over 88% within the service business only. Again, we have a huge installed base. I mentioned a service location in Austin, Texas. We're now developing plans to add a service location in the Southeast U.S., where a large piece of our installed base is, as well as a developing part of our installed base in the Western U.S. And again, for me, with my background as a customer, it's about trying to be as close as we can to a customer to best support them. Still leveraging the resources we have both within North America and globally, but again, having the right resources locally that we can support them quickly from any loss in production. One of the major investments we made, even during the pandemic when most companies were cutting costs, we acquired a new facility here, a service facility here in the Canton area, just a few miles from our office. And that serves as both a warehouse where we store, again, parts, but at the same time, it's a manufacturing facility for projects. We have a 50-ton crane and we execute many of the modernization projects we have through there as well. So again, that is a further expansion that, again, you'll continue to see from the company to make sure that we can support our customers better here locally.
Kevin, thank you for that excellent kind of overview of what Schuler's up to. It was great meeting with you today.
Yeah, thank you so much, Brad. It was a pleasure to sit down with you today.